All right. Hello, hello. Good evening, everyone. Happy New Year. And I'm so happy to see the full house again. My mic was off, sorry. Yeah, I'm so happy to see the full house again and all the smiling faces. So just before moving forward, can anyone from online confirm that you can hear me and see the shared screen?
I can hear you, but I don't see a shared screen.
Yes.
Now I do.
All right, thanks for confirming. So yeah, thanks a lot everyone for joining. I welcome you on behalf of the Meetup group, and today we have some discussions around Kubernetes workload optimization with Densify, and I would be walking through some of the presentation slide about what we do and some discount codes we do have. So yeah, let's go through it, and without wasting any further, we would be moving with today's topic. So yeah, first of all, I'd like to thank our sponsor, AWS, for this beautiful location. And we are really very sorry for the Meetup location goof up in the last minute. But I see all the people here, so that makes sure that everyone has read the email. So yeah, and Densify for today's event sponsor. And a little about housekeeping and logistics. Let's keep the place hygienic and let's return the way it was. And please don't forget your belongings, and please make sure you take it with you when you are leaving the venue. Thanks. A little about the group. The group runs across the globe. We have been adding some of the locations worldwide. This especially in Canada has been running for more than 1.5 years, and recently we introduced the India chapter as well. So it's growing on and on and on. The upcoming meetups, if you might want to, if you're traveling to some other country and want to join and drop by, feel free to do so. The main part, discounts. So as we are running this Kubernetes community, and we have been receiving some of the discount coupons from the Linux Foundation. So you could just take snapshot of this and apply those discount coupons if you want, if you are in the journey of your certifications with Kubernetes and Cloud Native. And yeah, if you might want to follow and join the newsletter where we try to share all the updates and latest technical trends, feel free to follow. And without wasting any further ado, I'd like to invite Andrew from Densify team to discuss more. And we have some giveaways as well if you see the table. So just be as attentive as you can and ask questions to grab those goodies and giveaways. So yeah, over to you, Andrew.
Thank you very much. I guess I'll try and use the mic and the mouse at the same time. Oh.
Hi, for online participant, am I audible and you see the screen shared?
Yes.
All right, good to go.
Okay, yeah, thanks folks, we're finally here. I'm Andrew Hillier, I'm the CTO and one of the co-founders of Densify. Densify is a company. Kubex is our latest product. I'm going to be walking through a bit today. It's not a product pitch. What we wanted to do was use it to kind of talk about the kinds of things that we see in our customers. We have quite a few big customers. We worked with a bunch of them to develop Kubex, so Paramount, Cisco, Disney, companies like that. They're advisors of ours to build out what I'm going to show you. And I'll try and relate to some of the anecdotes along the way as far as what problems we solve, how they're solving it. I'd like to hear a bit from you about if you have these same kind of problems, or maybe you don't know. Before I get started at the back, there's a bunch of colleagues over here. So anybody with a Kubex shirt, you can corner them if you have any questions, or corner me afterwards. But let's dive right in. And I have to stay close to this so everybody can hear me. So what is Kubex? So basically it's hopefully you can see the little screen here. So it's Kubernetes optimization, it's resource optimization, it's automation. Again, you folks probably talk about a wide range of subjects in this user group as far as all things Kubernetes. I'm going to zoom right in on just the resources, the requests, the limits, the nodes, node imbalances, out of memory kills, all that kind of stuff, with the goal of either saving money or reducing risk. And I'll talk about all these things and kind of what we're seeing. Our product obviously focuses on Kubernetes and OpenShift and all the variants. So if it's running on-prem OpenShift or in the cloud, EKS, AKS, GKE, we support all of those things. In the demo, I can show you different ones. So it's pretty cross-platform. And just kind of a note of, there's two lenses to view what we do through. One is from a FinOps angle, and one is from an SRE angle. And is anybody in the room in FinOps? Is anybody, a handful? I imagine mostly it's SREs and platform owners in this room on this thing. So we often will start interacting with the customer through multiple ways, but the big business problem that we see out there, and I'll just do this quickly, is that if you're trying to manage Kubernetes in the cloud, the tooling that you're using doesn't really zoom into it to let you know what's happening in it. So there's a big cost that's like the scale groups or the scale sets. But you can't just directly attack that cost because you have to kind of break it open, and I'll just build this out, and understand what's happening inside those resources. And when you look at the containers, there's often a lot of waste and there's often a lot of risk. So one problem we see, and I'm sure a lot of your companies see this, there'll be a FinOps team trying to cut cost, but they can't really go very far with a cloud-oriented tool. You need to go another level down and analyze all the resources. So that's often a starting point for us. Or on the other side, and I should say SREs there, but there's, okay, let's get rid of this. SREs and platform owners, and there's everybody wants to save money, but you want to do it in a way that doesn't incur risk. So that is very important from a platform perspective, that whatever we do, the apps stay running. And so that's kind of the tension that we see. And that tension has always been around. If I look at kind of capacity, if you will, and since the dawn of time, there's always been the struggle of having enough capacity without having too much. If anybody's worked in VMware days with capacity management groups, there'll be a group that's trying to buy servers to buy enough, but not buy too much. And they're trying to draw that middle line. Cloud kind of broke that a bit because there'd be a team looking for enough and a different team, FinOps, trying to make sure there's not too much. And it kind of bifurcated. But in containers, we see it comes back together because they're all intertwined. So if I look at all the stuff happening in containers, it's all intermixed. So you can't just go and downsize nodes and save money, because it really depends on what's running on those nodes. And really, if you think about it, the cost is incurred by what you're buying. Again, the SGs, the Carpenter nodes or the bare metal. But how much of that is running is being dictated by what the app developers and engineers are asking for. And that's really the problem, because they're usually quite wrong. I'll spend a lot of time showing you how wrong these requests and limits are coming out of those teams. Not because they're evil or they don't know what they're doing. It's just very hard to set these things correctly. And in the middle here, everything is intertwined. So, and we focus a lot on this. We've done a lot of R&D around this to say, I don't want to downsize a container if it's running on a node that's out of memory, or I don't want to upsize a limit beyond the size of my node, and that kind of stuff. It's all intermixed. So if you take too simplistic a view of this, you'll get something that will probably make your day very bad. Like we've seen cases where it can, you can have out of memory kills because you optimize something in the wrong way. So all this needs to be considered together, and that's what I'm going to try and talk about. So we approach it by doing a very deep analysis of all the containers. I'll spend a bit of time in this visual. I'll describe what it means, and understanding if the containers are set correctly. And then we also look at all the nodes, the node groups. Are they running out of resource? Are they saturated? Are they out of balance? And what instance types are they running on? And should they be on a different instance? And again, all this kind of happens. We call it full stack, because if you just do pieces of it, you might not get it right. But if you get it right, you have a full optimization of the containers right through to the nodes that they're running on. These could be scale groups, it could be Carpenter nodes, whatever that is. And when you get it right, that lower part will start to shrink, and you'll save money, but you'll also work better because you're going to avoid out of memory kills and other problems. So I'm just going to cover one or two more slides, and I'll pull it up live. Again, if there's any questions, there's a lot of swag here. If you want to try and stump me, go for it. But let me talk about this visual, and then I'll pull it up live. So this is something we developed, again, working with some pretty big customers, and it's basically a visualization of how wrong are the requests and limits. It's kind of the starting point for all this stuff. So on the top left are the CPU requests, and the top right are the memory requests, CPU limits, and memory limits. And the way this works is, and I'll just focus on the CPU first, the top left one, these bars are how many containers are in that bucket of sizing. So the green in the middle means there's about 1,500 containers that are good. They're set the right size based on their usage patterns. So we do machine learning on all the Prometheus data and all the node exporter data, and figure out, okay, based on what you're doing, you're set with the right, your request is good. If it's red, it means you're too small. And the further you go to the left, I'll try and highlight it here, this little bar down here means you're a fifth the size you should be. You only ask for one CPU, but you're using at least 5. or 10, who knows? So that red bar, the red is bad, and the further you get out is worse. And the gray is you don't have a value. So you didn't give it a CPU request value. In the other direction, this is too big. So this big bar here means there's about 1,500. This is an environment of about 12,000 containers, so it's not a huge environment. There are about 1,500 that have 2.5 times the resources they need. And this big yellow bar is 5 times or more. It's a 500% plus. So I've got thousands of containers that have 5 times the CPU requests that they're actually using. Right. So I'll pause there for a second. This is systemic. I've done studies across our customers. We took 7 of our biggest customers, like Wayfair and all these companies, and all of them have this problem. They all have this big yellow bar, which is where if you're getting cost pressure, usually there's a way to save it because people are just asking for a lot of resources. And again, it's not because people are greedy. It's mainly because if it's a highly replicated service, if you've got hundreds of replicas and you're looking at your Grafana screens, it's hard to get it right to figure out what to ask for. The analogy I give, it's like on my laptop. It's like me having to give PowerPoint a number of millicores. I have no idea how many millicores I would give PowerPoint, but that's kind of what you have to do in these environments. To a granular level, you have to assign these resources. So when we see that yellow bar, that's a cost-saving opportunity. So FinOps, if you have teams that are trying to save money, they love that, and we see that everywhere. And again, I'll pull this up live in a second. So we call that number 1. That's kind of a big cost-saving opportunity. Now, this is interesting. So memory tends to be much more complex. Oh, I'm sorry. Yeah.
This looks really interesting. What is the CPU thread? Is it looking at the peak CPU of that container, or is it looking at the average? Or is it looking at both?
It looks at both. So we build out models. So for example, for a replicated container, we would build models of both the peak, the busiest at every sample period, and the average across all of them. Based on that, because you might want to set the limit based on the peak and the request based on the average or the third quartile of the average. We do quite a bit of math in there, and you can use policy to control. But that's a very astute point. If request equal limit, like for memory, you set them both off the busiest because you can't have anything hitting this limit. So, and that's why the cost goes up so much for guaranteed QoS. So we do all those models, and then the policy says which ones do I want to use. Those workloads I want to base it on the peak or the average or whatever that is. I didn't talk much about how we work, but we also have a data machine learning period. So usually for a critical production, we'll look at 95 days of data and make sure we build a full pattern model of everything that thing does. So we're not going to clip it if it does something. If next Tuesday's month end and you set the limit too low, then of course you don't want that happening. Yeah.
I don't want to describe, but this is really interesting. I was wondering, from the data points that you've collected so far, how many times do you think ballpark? Was it something that was under-configured, over-provisioned, versus the app was designed in an inefficient way where it needed, I don't know, 5 minutes a day, it needed to be at this level, and it just couldn't scale that out?
Yeah, so I think what you're bringing up is kind of, we see a lot of workloads that are kind of not cloud native workloads running in containers. It's kind of, you're implying that, where it has a transactional pattern that has a huge peak and doesn't scale back. It's like a monolithic instance or monolithic container that just gets idle. And those ones are hardest to size for because you have to size them to their high watermark, and then you don't know what they're going to do. As opposed to if it was horizontally scaling, that would be better architecture. So we see it depends by industry. If we have like digital service providers, like more digital native customers, they'll tend to have a lot more cloud native looking workloads. Big financial services would have a lot of older looking, something they just brought over, but they didn't really rewrite it. So it really all depends. And every customer we have is different, and they all have different teams that are at different maturity levels as well. So,
I'm guessing the answer is no, but I'm going to try to ask anyway.
You're gonna earn one of these prizes very soon. So keep going. Yeah, no, this is great. Yeah.
Amazing. I'm pretty sure the answer is, but wouldn't it be amazing if this tool was also able to see, hey, the application is inefficient. So without having to look at the code itself and then figuring out, hey, the application is not cloud native.
Yeah.
And the tool spit out, hey, the app is not cloud native, so you need to refactor it.
There are probably markers for that. It's probably in the data that there are hints that's going on. We certainly don't read that out, just say, hey, this, but it's probably possible to identify these things. And I was having a discussion with one of our customers yesterday where one of the things that they're interested in is asymmetry across the replicas, especially if you turn on zone aware scheduling and the loads are wrong. So sometimes you can see that if your replicas aren't carrying the same weight, that could be, for example, a marker of something needs to be modernized or dispatched better. But it's a very interesting point. There's probably data in there that will let you recognize that, but we don't just kind of give a blinking light saying, hey, this thing, Obviously, something like JVM that's got a huge heap sitting there that that you can't touch. Like those kind of things are tough to deal with. That's a great point. And feel free to keep. I think we have plenty of time, so feel free to interrupt.
If I get the mic from him.
Sure. For the questions?
Yes.
Yeah. Oh, sorry, people. I should repeat the questions because people online can't hear the questions. So I'll just say they were very good questions. And just know that. Yeah.
So how long again is the base to create these statistics, I guess?
So we'll generate answers very quickly, and you can tune it in policy how much data you want to see. So you can say after 1 hour of data, give me answers. What we like to do though is, depending on the business service, make sure we've seen enough of a pattern before we start especially bringing limits down. So for a lot of our big customers, we will run that. We'll look at the last 95 days of data to kind of build out the model of what this, what the ebb and flow is of the thing. But it'll give answers much faster. It's just you have to be careful downsizing something off very short periods. In a lab, you can.
Is it missed? It's like, because let's say if you have a load testing, so where is it missed that people like they get like I get like inefficient like application like reverse,
Yeah.
but it's like where's there like the fault? Like you mentioned that like there is no load testing then basically. So
Yeah, and so the question is, I guess, why are they? I'm repeating for everybody online here. Why are they getting these numbers so long if they've done load testing and things like that? I guess if you've done diligent load testing, then they should be in the ballpark. I think what we see is if we have customers with 120, 150,000 containers, and they're not doing that for all those containers, and they'll just be something that's stamped out with, they gave it 10 CPUs and stamped it out and ran it. I'll show you an example. I have one in this deck of an example where, yeah. So if you're being diligent, you should get it right. Even though I do believe that even if you have it right and you're measuring it really well, it's still hard to set the right number across all the replicas and everything because it's hard to measure.
all the aspect of the memory, like all the CPUs, or like you have to add it up to what the node is capable of.
Yeah, but and then the difference between the working set and total memory. Yeah.
Rather up to run in the node if they run.
Yeah. So I mean, it's a good question. Why is this happening? But all I can tell you is it's happening everywhere. Like it's like really systemic. And yeah, so even the smartest companies, we find it, and I think it's probably just because of the sheer scale of these environments that when you have that many, it's just, you're just not, or they were right at one time and they're not right anymore, or that kind of stuff. Yeah, question over here.
In terms of the analysis you're doing, you provide some. In terms of the analysis you're doing, are you providing some feedback back to clients in terms of where they're going wrong, in terms of the way they're building models?
Well, absolutely. So we will generate recommendations. We actually have automation mechanisms as well. So we have a mutating emission controller that can change. We have Terraform modules. So I'll talk a bit about that at the end. As far as there's lots of ways to make it if you're ready for that. We have some customers that are completely automated, and others that just kind of start. But one of the starting points is you can get a top 10 list. I'll pull it up live and show it to you. You can just get right down to a top 10 list of the biggest problems and what to do to fix it. So yeah, that's the big thing. So I'll cut over live. Let me talk about two more things in this slide, and then I'll cut over live. So CPU tends to have this big yellow bar. Yellow means cost, basically, but memory is a little more complicated because we almost universally see a mix of yellow and red and gray in the memory. And what that means is that a lot of them are given too much memory. Like the far right of this, the yellow bar on the far right is 500%. That's one where you ask for 5 gig of memory and you're not even using 1 gig of memory. That would be way oversized. On the other side, there's cases that are red where you ask for only half the memory that you're actually using, which gets very dangerous if you do it a lot. And the gray bar is you didn't ask for any memory. There's no request. So that tends to be okay in the kube system namespace. So we often filter that out. For kube system, we say people not setting request and limits. But for everything else, the gray there creates a ton of risk because it means you might overstack your nodes. So when Kubernetes goes to schedule, you didn't ask for anything. It sticks you on a node. Then you light up and use 10 gig of memory and you blow the node up. So, and we actually detect that and we'll give a warning in the UI of that happening. So the red and the gray in the memory is more of a, again, we find SREs are more interested in that because that's kind of a tangible risk that I can fix. Even though there might be some cost savings, I need to fix it before I fix the cost, if that makes sense. I can't start downsizing containers when my node's already out of memory. And the bottom right, and I know it's hard to see here with the obscured thing here. I'll talk a bit about this one too. On the limit, we see a lot of customers don't set CPU limits much anymore, or they don't. They still do, but they're meaning not to. Another question for everybody: how many here set CPU limits, and how many set CPU limits? Okay, and how many have said, no, we're not going to set any more CPU limits. So there's a bit of a mix. So we give CPU limit recommendations, although we find a lot of times the big gray bar is fine there because people aren't setting them. But memory limits tend to be pretty important, and the gray there means you have a risk. You don't have any bounds on your memory, so if you have a memory leak, you'll blow up your node, and we've seen that happen. But the red is even worse. Red is I have a limit that's too low, and if I hit my limit, if the memory working set hits the limit, you get killed by the Linux kernel. And so we have detection of that as well, and we can warn you of that, and we see that everywhere as well. Again, I did a study across 7 of our customers. All 7 had number 1 and number 2, and 6 of the 7 had this happening, which seems, pretty basic to get your limit above the utilization, but it's not. Like we see it. I saw it again in another customer this morning that I was on with, where they hit the limit, you get killed. So these are kind of there's actually 12 different risks on this chart, and we have a poster with the 12 risks, but these are the 3 that we see almost everywhere. You've got things getting killed because your limits are wrong. You've got things getting killed because your nodes are out of balance. Some nodes are overstacked, some are understacked. And then you've got a big cost problem where everything's oversized, and these aren't virtual resources. You can't give them out multiple times. And so when you have oversized containers, you just have a lot of hardware or a lot of nodes running. So any questions around that? Yep.
Question on CPU request and memory. I think of CPU request as the minimum amount of resources you need for your application to initialize, start, and run.
Yeah.
So when you do this analysis, what point during the application startup you should these especially your memory requirements of CPU requirements?
So you need to be able to start up, but also you need to have enough so that when you run, it doesn't overschedule the node and cause contention and throttling, although it's rare that would be a problem. So, and I don't have an example here, but when you see a startup curve, usually it's a bit of a higher utilization, and it kind of settles down. And you can tune the policy to ignore, you can say only take the 99th percentile of data to get rid of any startup spikes, and then only work with that. So you can kind of filter out the noise that way if you don't want to size it to the startup, or you may want to size it to the startup depending on the nature of the
also
policy.
Take the time base, for example, application starts from time 0 a certain period of time, you consider that at the startup before your help points come up, something like that.
So that's something we actually had a recent discussion on. So we don't currently have a policy for that today, saying like ignore the first n seconds after you see a new container. We're talking about adding that, but you can achieve that by just saying drop the nth percentile of the highest data, and so that tends to have the same effect, which is what we do. So sorry, let me flip over and show you the product. Where did it go? It's in this tab. Okay. And I think I will F11 that. Hard to hold a mic. Okay, so now I'm live in the product. It's kind of what I just showed you, but a much smaller environment. So first of all, and it's kind of obscured at the top here, so you can't. I'm not sure if there's a way I can hide that. I can drag it away. So this is an environment of about 2,300 containers. So, sorry. So this is this is a bunch of internal labs. This is not. I'm not showing you a customer data. This is actually our data. Coincidentally, it actually has the same pattern that we see everywhere. But let me step back and describe. So I've described kind of the histogram. At the left, you see I'm in the container area. There's also a node area. So let me go there for a second and talk about the nodes, because this is very important. So we do an analysis of all the node groups and all the nodes. What kind are they? You can see there's a mix of some Amazon, some Azure here. And I won't try and describe all these numbers on the screen, but we're looking at what is the, we're looking for 2 things: node saturation and node imbalances. So are any nodes in the node groups hitting the roof and running out of resources? And are there any big discrepancies between nodes? So one node's running at 80%, one's running at 20%, because those are indicative of scheduling issues. So if requests are all wrong, the scheduler will get all out of whack. And again, this is a lab, so there's, I can sort it by the, we're actually using a lot of memory and not a lot of CPU in this environment. But when you look at customers, you see all kinds of different things here, and I have different views, and I can look at health or capacity views, and I'm looking for in here things that are out of balance or things that are saturated. And I won't spend long here because all of this will be shown again in the container analysis. So all of this is done just to make sure when we know when a container is running a node group, is the node group healthy? And I can even get down to the individual nodes and, say, let's sort them by their utilization and, view all that at the bottom here. So I can see everything the nodes are doing and whether they're running out of resources, or again, I don't spend long here. If they're running out of resources or if they're out of balance, we want to detect that at that side. So on the node front, we're going down to a detailed level just to make sure we understand if they're healthy or not and how much space they have. And that's in this node section. But I won't spend long here because it's easier to understand what that's doing when I show you through the container UI. So going one more level to the right, just so you know, I'm looking at it in a tree view, and these are different clusters. And I can actually view different clusters. I can view it by business unit. I can view it by cluster, by namespace, whatever I want. This is cluster, namespace, pod, container. And so I can navigate however I want. I can make my own breakdown. I can filter and say, only show me the things without kube system, only show me Nginx across my whole company. And quite frequently, we just start by running this whole map on the whole company. Again, like recently I was doing 120,000 containers. It's like an MRI of your whole company. Yep, you've got some spend problem there. You got a lot of unset memory requests. You might want to look at that. And you've got some kills. And unfortunately, I can't move this this video screen down here, so it's not coming from my screen. So, but there's a lot of problems with memory limits as well. If I click down the clusters, I'll just see this for different clusters. This is pretty practical. We have customers where they run similar setups in Europe, APAC, and North America. And when you click between them, they don't look the same because they're not setting them up the same way. So it's kind of interesting to be able to click your way through clusters and see the picture change. It'll probably be okay if that stays there. So now I explained the structure of this. Let me just talk about this because we've done a lot of work to make this kind of one click. So I'm looking at my whole company, and again, you can see a bit of red in the memory down here, just tucking out right here. That stuff is the evil stuff. That's this gray is not good. 746 containers don't have memory limits. Sorry, there's a question back there. Yeah. So that's where, so back to, it's doing machine learning on quite a lot of data. Like, and typically we'll look back 95 days, but we can weight it different ways. You can say how much you want to look at. And then it's looking at the operational patterns to figure out what should your request and limit be, which is one separate process that say, well, I don't want to request to the peak. I want to request to the, the sustained activity. This is showing us the ratio of what we're recommending it be to what it is right now. So this is kind of downstream of that, saying after analyzing all that data, we're saying that you're set wrong. Your request for limit is set wrong. And these limits down here, we also do track them. I'll click down. We also track them, the amount of restarts in the last day and in the last week as a result of that. Yeah. Well, let me drill down. I'll show you the time sliders at the next level down. But the policy is kind of dictate when you come up with a recommendation. The policy dictates the time frame, so you absolutely can control the time frames. So I'll drill down and show that. So why don't I go down right now? So I can click on any of these bars and get a drill down onto what these things are, or I can click on one of these warning symbols. These mean there's a risk. These mean there's a cost savings opportunity. And I'm just going to start with this one because this one's the most fun, I guess, or the most scary. Memory limit events. So what we're saying is there are cases where the limits are set too low, and we are detecting that the memory working set is hitting the limit and it's causing a restart in this environment. And if I drill down, now I get to a view that shows me the top offenders. So in one click, I've gotten down to here's the top 10 list, of top N containers that the limit is set too low and they're restarting. And I can see that because if I scroll to the right here, you can see the algorithms are saying there are events occurring. And these are the restarts in the last day. So we track the restarts in real time, but these ones are restarting quite a bit. And if I click my way down here, you can see this, and again, it's kind of slightly obscured here, but you can see these curves down here are showing me the workload patterns of these containers. So let me pull one of these up. So this is CPU of the busiest replica, CPU of the average of all replicas, to the question earlier, memory of the memory utilization of the busiest container and the average. And I'm just going to pop this open and explain what this is looking at. I'm just going to turn off the request so I can see the curves here. So this is what we call the machine learning model. So it's taking all that data, again, however much history you want, and it's learning the 24-hour pattern of this workload. So this will kind of show you 9 a.m. start, goes down, busy again at 2 p.m., whatever that is. This is a lab, so this one's just kind of flat. This is where you see kind of the actual characteristics of the workloads. We have customers that say this is one of the biggest things that they can understand what that app is doing from a pattern perspective. And this one, the way you read this is that's the memory, total memory going up and down between about 20 megabytes upward to 96. It looks like I can actually click on it and get the actual numbers. And so it's actually fluctuating, and the blue zone is where it's spending half its time. So we do it by quartile. So it's reaching as high as the thin part, as low as the thin part, and it's spending half its time in that middle blue part. And this tells us quite a bit. So we know this thing has sustained activity upwards of 90 meg of memory usage. But the limit is sitting here, and it's hitting its limit. Visibly, you can see it hitting its limit. So the algorithms picked it up, but we can actually see it here. And if I scroll to the right, I can see other metrics. So this is the average container, and this is the restarts. So we're seeing between 3 and 4 restarts every hour of the day. So this is a typical pattern you would see if the limit's set too low and you're hitting the limit. This thing will keep restarting and restarting. And a lot of apps are architected to survive some restarting, but probably not a ton of restarting. Like when we've seen DNS servers doing this, we've seen Prometheus servers do this a lot. And if it keeps bouncing, it's very disruptive and queues fill up. So usually when we find these, there's something you want to fix very quickly because it's entirely preventable. You just have to, we're recommending the limit be up here. So the limit is at 96 right now, and we're recommending the limit be up here around 150, and that'll fix the problem. It won't even cost you anything to move the limit up. It's just causing added memory kills. Is that all making sense? Any questions? Yeah.
Sorry, how exactly does measure the memory utilization? Is it just the working with type container, or it also includes the page gap utilization? I'm more thinking of the data that's related to those are even at this heavy load where page gap consumes most of your memory.
Right.
Yeah.
So I think this is the RSS, and then the working set is the one that we focus on, which and maybe Roy or someone we can pull up. I think it might include the page caches, but not the buffer, but not memory map files. So for example, we'll see I don't know, like an Nginx server or something where there's a huge discrepancy, but there's a lot of memory map files. So the total memory is hitting the limit and it's getting clipped there, but it's just clipping the caches. It's not actually affecting the heap. Yeah.
Those cases, like just to have more things of like page files or just efficiency.
Yeah. Yep, and it's good to tune the policy for that too, because if you click too much, that cache is doing you a favor. Like if you don't want to, you can say, oh, it's just hitting the cache, it's not actually hitting the heap. But of course, that's a performance problem if you start really clipping down. So we see a lot of times where the sustained will flatline at the like the blue bar will be hitting the purple, meaning you're actually just stopping anything from happening above that level, and you're not getting restarted. So you'll see that as 0 restarts, but you are hitting your limit. So, and we also find what we call hidden kills, which aren't so much a problem anymore, where it wasn't process ID 1 that got killed. And so the thing keeps running without a process. And we saw a ton of that. And we still see it, but that's kind of going away in 127, I think, or something. So,
if your policy is all SRE or engineer to create complex policies on top of what you have to policy, right? Let's say June metric, right? From what you measure for your
so there's several layers, as far as customization, you can absolutely tune the policy. We tend to work with people but you can do that just to make sure you don't do something crazy, because you don't want to cross over the policies for requests and limits and stuff like that. New metrics can be added. It's a little more involved. Again, Roy at the back here is one of our guys who does a lot of the metrics and adds them all. So you can ask him how that's done. So it's pretty tunable. Yeah, and what we focus on is trying to the point of these questions, get it right. Like you don't want to generate a wrong answer and automate a wrong answer. So we want to make sure whatever we're doing, you don't want to downsize the CPU if HPA is scaling on the CPU because it scaled. So there's all kinds of considerations to make sure you're getting the right requests and limits. It's pretty involved. While I'm here, I'll show you. This is the 24-hour pattern model, but I can also look at the actual historical data. So I can look back. In this case let me just scroll this. I can look back the last 95 days of data by day. I can look at it by hour. I can see what the requests and limits were historically. So you can see here, so I can actually see the pattern models, the actual pattern models at noon last Tuesday, or the raw Prometheus data. So you can view it all right here. So we're not trying to replace Grafana. We just want it all to be in one place. So if we're giving a recommendation, you can drill right in and say, I'm not sure I'm seeing this come up here. let's give it a second. So I can actually go and see all the raw underlying data for each container. For some reason that's not coming up, but while they're waiting for it. So again, so that use case is I've got things hitting their limits, causing out of memory kills, might cause reliability problems. I can come down here, I can see the recommendations, I can see all the curves right here. I can even click on the container, and each container has a home page with everything about it. And you can share a link to this to others in your organization. So we have users, customers where there are teams, whoever owns this container, I can send them a deep link to this, and then they click on it, they get right into this page, and they can see all their data, and they can see, you know, this one's hitting its limit. It's also running on a node that's out of memory. Here's all the recommendations. Here's all the utilization curves down here. So again, you can very rapidly get to the top 10 list and to the actual solution for limits. So that's one kind of ramp down through here, which is oftentimes the first one we look for, because those are causing real problems and they're entirely preventable. You can just go and fix those, and make sure they don't happen again. I should do a quick time check to make sure. Are we okay? I'll just keep. Yeah. Let me talk about this one for a second, because this one's a little more complicated, because the problem isn't something can be undersized and it creates a problem in aggregate that affects somebody else. So I might have a container that has no request, but it may or may not be the one getting killed. And you see here, we're detecting that you've got undersized containers and there are nodes that are out of memory. So I can see that it's likely happening because there's a whole lot of things that are sized wrong. But if I click here, I'll just get to my top 10 list of undersized containers. So here's one. It's a Prometheus server. They tend to be a bit of a mess. It has no request at all, and we're recommending it have a request of about 8 gig. And I can see that down here. So this one, there is no request value, but it's using about 8, upwards of 9, 10 gig of memory. So we're suggesting you should give it a request at its sustained memory usage. So that's just a pretty straightforward example. If I go down a few, this one has a request, but it's way too small. So this one has about 800 meg, but it's regularly using, over 3 gig. So we're recommending the request be brought up to here from here. So these ones, they may be running fine, but what they're causing is they're causing the nodes to overstack, and something is probably getting killed in this environment. It may not be this one, it may be somebody else. The ones that are the highest over the request are typically the ones targeted. So even though this one's set wrong, it's not actually getting killed, but something is. So when we see high restart activity in an environment that looks like this, it's a good idea to upsize the memory on these things so the nodes calm down a bit. And again, is that all making sense? Yeah. Question over here.
Automatically implement the recommendation?
Yep, there absolutely is. So I'll get to that towards the end. So first, you got to make sure you have a recommendation that's correct, which is kind of what Nostalgia now. And then, of course, there's multiple ways you can actually do. I'll talk about how some of our customers do that. So I'll do that in a few minutes. So anyway, this is the case where these ones in aggregate are creating a pretty big shortfall. In total, these ones, they're creating 117 gig shortfall of what they should be asking for versus what they're actually asking for. And that kind of gap, again, tends to cause the nodes to get overstacked and makes the environment unhealthy. So we see that almost everywhere. I think we did see one customer that was pretty clean in this sense, but almost everybody has cases where they're all out of balance. And I can see that if I scroll to the right. So if I keep going to the right, I get all the node information. So this one's not only too big or it's undersized, but it's running on a node group that is out of memory, and memory is the primary constraint. So this one's a really important one to fix. So we weight all the recommendations based on, are they going to make a difference? So these ones will all make a difference because they're all in a node group that's out of memory. If I was in a node group that's out of CPU, it may not be a priority because it's not a problem. It's still a good idea to do it, but we track all the node level data to say, if we're recommending something, is it a priority to do? So this top 10 list is the ones that are way too small on node groups that are having memory problems. Yep.
I really like the cost savings column. That was towards the end. That's great. As a stakeholder, it makes this valuable for me. I was wondering, is it looking at when it calculates the cost, is it able to calculate the cost, keeping in mind the prices for the containers running in Azure versus AWS versus GCP? Yeah,
so you can set the price. So there's a subtlety there. It's a great question. So when we're calculating the price, this is working off a per memory and CPU costs that's tunable. So we typically tune it to what your cost will be. We also do cloud optimization. I'm not talking about that today, but we do that for like the scale groups underneath these things. That can actually also go get the real cost data and factor that into the analysis as well. So there's various ways to do it. This one is just working off a kind of a rate that you give to this. There's a subtlety there too, because there's price per CPU and there's memory, but then certain things you do save a whole node and save the CPU and the memory. So sometimes you can do a CPU downsize that saves more than the CPU cost because it lets you turn a whole node off, if that makes sense. So it's kind of complex to calculate the price, but there is a price column, and I'll go to that next, the cost savings. Is there another question?
Yeah. Where like, hey, we're committing to $100 and all of a sudden it's going for that.
So this doesn't directly, that's another great question. Is this taking into account that you have a commit level that doesn't matter if you go one fewer node? This isn't taking, the cloud side of the product looks at stuff like that. So as far as the commit levels and what you're doing. But yeah, that's a very good point. You don't want to start, I don't think we've seen it in Kubernetes environments ever where somebody brings themselves down below their commit by cost saving, but yeah, it is possible. Most people we see hit a certain commit level that's not 100% of their spend. So there's some elasticity to save in these environments. So let's talk about cost for a second. That's the last area. I've talked all about all the risks, all the red and the gray, which creates all kinds of different risks. This yellow bar is the one, of course, that like a FinOps team would say, click that, because that's all this money. So these are the ones that are way oversized for CPU. So this top one, for example, it is 30 replicas and they've been given 4 CPUs each, and they're 2.3 CPUs too big each, right? And I can kind of see that if I pull open this curve down here, I'm asking for that much. That's the learned pattern. It never goes above this level in all of history that we've seen. It's never gone above that level. So we're recommending the request be there. You could even recommend the request be down around the sustained level. That's even more efficient. And it's highly replicated. I'll flip back to the PowerPoint for a second, because there's an example of this one in the PowerPoint that is a real example. So this is, if you look at real data, this is not the real data. It's not the identities are hidden, but this is a scenario. We see this in almost every big customer, where this one has 200 replicas of, it's not actually an OTel collector. It was another container, but it's been obscured. They were 8 CPUs each, and they were 6.3 CPUs too big. So, and you can see the curves at the bottom. That added up to 1,266 CPUs worth of capacity that was completely stranded because these containers were too big, for about $27,000 a month of spend. So highly replicated, way too big. They just gave it a ton of CPUs. None of the replicas were using those CPUs. And it ended up costing, at list, it was $324,000 a year in one container configuration, one launch manifest. Yeah. Please.
I feel a little bad for asking all these questions.
No, they're great. Good question.
I really like the idea that, yeah, looking at the CPU, like, thank you for explaining that. I was also wondering, does it look at the type of the CPU? For example, if you're using a CPU that's costing 3 times more versus a lower capability CPU, does it take that into consideration as well?
So on the cloud side of the product, so again, I'm talking about there's Kubex is the container side, and it's the containers down to the node groups and the nodes, like I showed. Then it flips over into our cloud product where it's doing scale group simulation and looking at the actual catalogs. And there's a whole side of our product that does that. It'll actually analyze all the instances against the entire Amazon catalog. It gives you a visualization of it. And it will choose, they'll look at the core speeds. It will look at, like if you're using GPUs or not, that kind of stuff, to choose the exact right node type. So a lot of the times, for example, it'll push you like onto an R7i or something like that, because it's got faster cores and it models all the benchmarks. So that's kind of the cloud side doing that. So which talks to like they're connected, yeah. So that's that whole stack thing. So we absolutely look at that, and a lot of times, for example, you're running on like an M4, and you'll say no, move to an R7. You can go to a size down, and because of Moore's law, and it's going to be faster cores and cheaper and everything. So yeah, that's kind of the underpinning part of that. So that's just a real world example of, this is a lab, so you're not going to save a lot of money in our lab. But these are all the containers that are ranked by how oversized they are. That if you went down this list and started reclaiming, there are, in this case, 200 CPUs worth of waste in this set of systems. Now, this is where I kind of say, but not so fast. Will this actually make any difference is the question, because like I said earlier, downsizing CPUs won't make a difference if memory is my constraint. So if I go over to these guys, you see here, these are the node groups that the blanks mean that they're in multiple node groups. So these are the ones that are in specific node groups. And this is, are there any nodes that are out of CPU? Nope, we're good. So it's safe to downsize the CPUs. But, you know, memory has some issues, but these ones are all memory bound. So I can downsize CPUs all day and I'm not going to free up any nodes because I'm memory bound. So in our lab, actually, in our lab, I should say right now, they come and go. This is a live thing. There are none, I don't think, that are CPU bound. Some are memory request bound, some are memory utilization bound, but none of them are running out of is CPU the problem. So if I'd be completely wasting my time to go and downsize these containers if I'm trying to save money. Now, if I downsize enough of them, I can move to a memory optimized node. So there's still a reason to do it, but there's no instant gratification here. So this is what we call a realizable gain, where if something's too big for CPU on a node that's CPU constrained, you downsize it, you save money pretty much right away, like as soon as you do it, because you can start running on fewer nodes. In this scenario, you can still do these downsizes, but you might want to then reconfigure the nodes to be a different type of node. And our analysis will pick that up and say, okay, you've gotten rid of enough of your CPU requests, you're below half the capacity of CPU requests, we're going to flip you to a different type of node. And that's where you get the money savings. So again, that's so the money, I know this is a bad data set because it's just a lab, so there's not a lot of realizable gains, as we would call it. But that's what that's representing. And in a real environment, you click on that, you see all kinds of opportunities that are ranked saying, here's the best things to go after to save money, which every company likes. Yep.
We've got a lot of capability, right? Because you're looking at stuff, the ability to just isolate as well. Right?
Yeah, that's a good point. That's Riaz. That's the other co-founder of the company, by the way. So in this table, one thing I didn't show any detail. What I'm in here, it's a pretty powerful. So what we've done, and I should back up. So KubeX, you know, I talked about how we worked with advisors to develop it, and we kind of completely did the user experience for KubeCon in Salt Lake City. And one of the things that we wanted to do, that's where we announced it, was basically almost embed Excel in the product. So these tables, when I'm using them, if you look here, you can filter, like it acts a lot like Excel. I can go and actually filter things down, choose only certain things. I can sort on any metric that I want. I can actually pivot. I can actually even chart from here. So this thing behaves like Excel. And I'm in the CPU request surplus view right now. But what I can do is I can modify this. I can say, let's add some new columns to it. Let's go and add total surplus, total surplus requests. Let's go down and look at I don't know, like the number of nodes it's running on. All the output of our analytics is available, and I can start adding columns to this, and I can actually save it as my own view. So what this means is you can make a view that's whatever you want. It's focused on your containers. That's a risk view. You can make a FinOps dashboard out of this, and you can save it and you can share them. So in here, there's private views, there's shared views, and we build in a whole bunch of system views, which are around risk and waste. So this component itself is an extremely important piece because it kind of has, it's like having Excel right inside. You can kind of massage the data, save it, you can share it. It's all deep linkable and send a report to someone else. So we find a lot of customers end up making various reports. In this, you can make a live report that I can just send you a link, and it's actually a live view of your top 10, risks in application X. So, yeah, that's an important thing. I think we had a lot of requests from our customers around making this customizable. And again, if I pop on the side, it behaves a lot like Excel, right embedded in the product. So, I think I'll stop there on the live demo. Hopefully everybody gets it. It's kind of it's important to get this right. Again, from a resourcing perspective, we find universally they're wrong, like very wrong in a lot of companies. It's identifying them and prioritizing is very important, and making sure it's safe to fix, which again, I've talked quite a bit about that stuff. Memory can be very complicated. There's oftentimes very, very quick hits from a risk perspective and from a cost perspective. And then the last thing is that already asked about earlier was automation. So I'm just going to flip through here and talk about automation for a second. And this is just a deck with similar examples of what I've been showing. So let's talk about automation. We support a whole bunch of automation mechanisms through our APIs. This is one customer, and I'll just name names because they're a reference case study for us. It's on our website. And this is an OpenShift on-prem example. I think it's running on VMware actually on-prem. And so this is their deploy pipeline. And what they did with it was So we're analyzing all the workloads and doing everything I've described. They just hit our API every time they deploy. I'll just build this whole thing out, and put the new values in the OpenShift templates every time it goes out. So it's a pretty cool example because they had a lot of control. They didn't have a lot of arguments with their internal customers or whatever. They just said, let's do what the machine says and make it right. So this is a great reference case. It's just completely automated. All the requests and limits are always set to what the analytics say they should be. And these are their histograms. So this is what good looks like. And what good looks like is there's no gray. So everything has a value. Like the hygiene is really good. Vast majority of the containers are green, which is what you want. The reason why there's still some yellow and red is because our policies also limit how big a change you make at any one time. So if you have 1,000 millicores and you're using 1 millicore, we won't take away 999 of them in one step. We'll take away, it's at 5x is our kind of our default. We'll take away 80% in one step. That's configurable. So usually you still see stuff out in the wings where it takes multiple iterations to get it converged on the right answer. Yeah, question?
So let's say you fixed the problem a week ago, you're still looking at 83 days of old data, let's say, and that.
Yep. Well, so you can initiate we have what's called a relearn. So if you reconfigure things, so it depends on the scenario whether you want to use that or not, because if you change a request and limit, it doesn't change the utilization behavior. So the history is still valid. Like for example, in a cloud instance, if I resize a cloud instance, you toss all the history because it's now going to do something different if you change the size on a different CPU architecture. But generally, for most of the scenarios and containers, you don't have to invalidate the history because they're still doing the same thing, just with a different request value. If you bump up limits, you might see the utilization go higher, but that'll just get picked up right away. So these guys, pretty big success. Yeah, they actually saved. Unfortunately, I don't have the chart to show this, but they cut their new infrastructure spend in half doing this. So that was a really good, kind of reference example. It's on our website, and I did a podcast with them a couple of months ago. And so I think automating it this way and letting the machine figure it out, they call it a game changer because it just fixes this mess that was being made by all the people. So that's one automation scenario. That was kind of a do-it-yourself. They're just hitting our APIs. A more canned one, and this is another customer of ours, one of our advisors. They started by using our Terraform module. So we have a Terraform module that works for cloud and for containers. So instead of hard coding values in Terraform, you put a line of code in there and it'll reference our API and make it right every time you deploy. So it's the same pattern. It's just, it's less work. You don't have to code anything. They started with that, but they were in a real hurry to save money and they didn't want to go to all the app teams and touch the Terraform. So we took a different angle with them. So we were working on a mutating emission controller, which I'm sure a lot of you in this room are aware of. And so we kind of accelerated that for them and got it deployed, and they got it deployed very rapidly and started automating using this. So the way this works is if there's a label on the containers that enables the automation, then the emission controller will hit our webhook and basically update it to what the optimal value is. And it just goes out optimal. So pretty simple. It's actually very fast to enable. You can enable it broadly or you can just enable it very narrowly. Like in this case, we just enabled it on some containers just for CPU request downsizing. And not because when you start bumping things up, you start to get in the quota, you have to watch the quotas and stuff. So just that narrow use case, they got it running very rapidly and started automating that. So again, just a couple of different, some different automation scenarios. We are also working on a in-place resizing. It's not widely available yet. It's still kind of early for it, but the way this one works is when we don't restart the container. When it restarts, like if it's a deployment, when something gets started again, it'll get the new values. Or for replica set, it'll get the new values for new replicas. You can restart the whole thing optionally, but we won't force it. It'll kind of do a lazy resize. In-place resizing lets you just resize them as they're running and not restart them. So that's kind of coming soon. That's the next automation mechanism. Yeah, question?
Traffic than what the model previously seen. New traffic does it sort of adapt quickly to the changes, or what do you tell customers to do in that scenario?
Yeah, so the policy for up works very quickly. The down is the slower one. So if you see something, if something shoots up, then the very next analysis will catch it and say go higher. But that's also why usually an environment where the limit isn't too restrictive will survive that anyway. Like as far as it going up, as long as you're below your limit, you can survive that even if you're above your request, and then it'll correct over time. So we like to think that a correctly sized container can absorb a certain amount of shock without any resizing because you didn't place a limit too low. So we like, you know, we like to see set limits, but they can be quite high. They don't have to be hugging the workload for that matter. So, but yeah, the policies to go up are, as soon as we see a higher samples, we're going to say, okay, no, get that limit up quickly. Yep, and we can also work in conjunction with VPA and things like that to, you know, it's also very good at doing rapid resizing. So I think that's it. There's one last slide, just kind of tie it all together, I guess. So you can think of what we do as if the tech. Oh, sorry, Dave. Yeah. Yeah, Argo CD comes up. I mean, Roy, the question about Argo CD, if that's managing the app, I think it's a similar mechanism. I don't know if you can speak more, or we can follow up afterwards on that question. But yeah, we do see that. So I think it's similar mechanisms, although I can't speak to the exact details of it, but we've seen that. So and again, just the last slide. So if you consider like these Tetris blocks are the workloads and the dotted lines are the requests, and they're kind of wrong, you know, basically the way I've been describing is taking those workloads, learning the patterns, analyzing it, and coming up with new values for the requests and limits. Could be up, could be down. Usually it's kind of in all directions. And you know, fixing risk, fixing waste, and then when Kubernetes redeploys, the request value is more closely aligned with what's actually going to happen. And so one of the key points here is that we don't mess with the Kubernetes scheduler, and we don't mess with the autoscaler. Like people, our customers, they tend to like to use the standard out-of-the-box components. We just make it work better by giving it better inputs. So it will automatically work better if you give it better inputs. And so, for example, when we do that, Kubernetes will automatically start running on fewer nodes, just because you don't need to schedule all that stuff out. And that's great. And Carpenter will also do this. Again, with the right pod disruption budget, it will actually start rolling things over and consolidating quite nicely. At some point, though, what we tend to see is the node type will become the wrong type. So usually because CPU goes down more than memory, usually there's a lot of wasted CPU. So as we bring the CPU down, then the node type becomes wrong. And that's where our cloud analysis comes in, which I was kind of describing earlier, where that will look at the actual nodes and the cloud catalog and say, wait a minute, we're going to put you on a different kind of node. We're going to take you from an M to an R, and maybe also put you on the latest R while we're at it. And so that's constantly happening on the cloud side. So that's what I was describing earlier. This is a diagrammatic version of it, because once you've optimized quite a bit, again, the node type will become wrong, and usually moving to a memory optimized is going to save you another 30% on the bill. So and you'll get faster core speeds on that model. So that's kind of constantly happening. So that's why I was describing earlier is the container side and the cloud side are kind of working in unison. If you're running on-prem, it's a bit different. Of course, you don't reconfigure the nodes, and it's more about freeing up, you know, purchase avoidance of not having to buy new nodes. But in the cloud, it'll dynamically. We're working on a video right now of just showing this working with auto mode and Carpenter, and how, you know, using the mutating emission controller changes it, and then Carpenter starts consolidating, and it starts, you know, gaining efficiency. So that's kind of the end-to-end optimization. All right, so I think that's all I was going to cover. I think we have a lot of stuff to give away, though, and I think I'm not sure if you were going to do a chat or what comes next.
Sure. So first, if someone have any questions from the audience about the presentation, feel free to ask. Or after that, Andrew might be taking test and he will be giving your Q&A. So if you have some questions, one or two, maybe first let's address the
the questions. Yeah.
What's different compared to like perfect scale?
So there are there's other products in this space. So Perfect Scale was the one that was, and there's Cast and other ones like that. So what we tend to do is we would, I think, hopefully I stress it, in the depths of the analytics as far as coming up with the detailed answer to the machine learning models and making sure they're safe and effective. I think we go far further than everybody else. Some other vendors, for example, focus on overriding the autoscaler or you know, overriding. So some of them take the approach that they're going to actually change the scalars itself or the HPA. And again, we focus on doing the better analytics, but not messing with the standard components, if that makes sense. So there's a bunch of other vendors there's you know, there, I'm sure you've seen them all. Now, I did have a slide. It's a pure marketing slide, but it's probably relevant to this question. We are ranked. We've done a lot of work with analysts, and we are ranked quite highly. I don't think we're this far ahead of a Cast and people like that, or Stormforge. They're great products, but when you dig into the details of the policy and all the depth of the analytics, it comes up with a superior, in our opinion, a superior answer. So, and there's been some independent verification of that. But again, that's kind of a salesy thing. So I won't dwell on that. Another question? Yep.
There is a goes out of the node, or you still analyze where it's on it.
Sorry, not sure I followed the question.
Can you still determine how the scale of the issue? Because it basically goes out to the day across the threshold.
Can we, so on the nodes, so I mean, I'm not sure I follow the question. So we look at the nodes and we look at the utilization relative to the aggregate requests and see if they're way over that. And we flag that as like the imbalances I was describing. Now, we don't directly change the node to fix that. What we do is we fix the requests that are going onto that node to make sure they're not out of whack. So if usually if there's you mean like just doing like a predictive analysis of like we don't, if we change it, we will measure what it currently did. You're asking if it would predict what would have happened if you didn't update it? Is that? You mean like, so if you mean like an out of memory kill, is that what you're referring to? Like something got killed so it wouldn't have hit? So we don't actually get, I guess you're asking if we simulate what would have happened if it didn't get killed, but I'm not sure it would have just hit the roof, I guess. So we see that. Yeah. So the thresholds are coming off like the measured container level data, and then they aggregate at the node level. So if they aggregate up too high, we'll just see the node hitting the working set of the node hitting a high level relative to allocatable, hitting too high. And that's what you see in those curves in the node group. But I mean, if something that's happening, Kubernetes will just reschedule on a different node. So you can't draw too tight a conclusion between the node itself and what containers were on it, because they may not be on it after the event. So we look at it more, that's more at the node group level. We look at the aggregates to say the whole node group has these aggregates. But we want to avoid individual nodes becoming saturated and having that problem in the first place, which by looking at all the requests and limits of all the containers that could run on it is kind of the path to stop it from happening in the first place. Yeah, hopefully that makes sense. Yep. Another question in the red?
Yeah, thanks for the presentation. Very small question that I had is in the slide where you were showing that give a recommendation.
Yep.
In terms of this is what the memory is said, and this is what the nodes are actually using. So you have that yellow dotted line, right? Where you move 90 days history and whatnot. So I thought that it's a little above. So what's the data amount that you normally give for your recommendation?
So let me see if I can pull up what you're asking, and I'll pull up this one. So this is the case. So the solid line is the request and the dotted line is the recommended request, and policy tunes what we recommend. So this one, so you can say, set it to the peak of the busiest of all the replicas, or set it to the, so this is the busiest, I don't know, let me see, this is the busiest container. This is the, no, that's the disk IO, sorry. CPU busiest. Okay, this one doesn't have, let me find one that does have multiple replicas and see, okay, this one, but this one has no utilization. So basically you can tune in the policy what criteria you're going to set it to. Is it the peak or is it the sustain, which is the blue zone? And this is a bad example as well. Let me go back to another one. And is it of the busiest replica or of the averages? So, this one has a little more workload to work with here. So we can make it to the very top of the peak, or we can make it to the top of the blue, which is the default. The top of the blue for the average replica is our default, because that's a good balance of, in aggregate, you're not going to over request too much. Things can burst above their request. And then the limit, we like to put it, I believe, 50% above the peak of the peak we've observed of the busiest replica. Just get it out of the way, but still have a limit, right? So it's all tunable. It's all tunable in policy. And then if you're doing guaranteed quality of service, like for memory, then both the request and limit would be the same value, and they would be above, a comfortable zone, I think 25% above the observed peak. but you don't, but that's really costly. Like that gets really expensive if you make that policy higher. Yeah. Yep. Oh.
I think you touched on the database earlier. For any database system or system that has dynamic memory management, right? So what are your thoughts on
Yes, the question about JVMs, and we do hit that. So right now, I mean, it is possible to do an integration to get the JMX metrics and get that, but we don't do it out of the box right now. So usually if there are JVMs running, we would kind of just reflect that in policy. So the question is like the MXMS, if it's really high and the observed utilization is low, we don't want to be bringing them down. So it's, again, the best way to do that would be to actually get the metric and add it to the analytics. That's usually a bit of work. Like I find that creates a bit of a project. So I think we might have done that at one point with like Disney or something like that, but it's most of the time now we just kind of tune it as a separate policy saying, yeah, if you have the data flowing in, we can look at the data if it's being integrated in. And again, I don't want to overstate. It's a bit of work to get like the custom metrics in. The other thing that comes up with JVMs and one of our big customers, I think it's Transamerica, the garbage collection dictates these amount of certain number of CPUs as well. So downsizing the CPUs on a JVM can also impair garbage collection. So you just kind of got to be really careful with it. But there are ways to reflect it. But it's, again, I'll just say it's a bit of work. It's like I can't say we have all our customers doing JMX metrics to solve those.
Online, some of these garbage collection metrics doesn't have to pertain to the system. If it's supposed to your product, then there's all the system.
Yeah, then we would just, yeah, there would options to deal with that in policy. Exactly. Yeah. That's a question. So there's, I mean, it's the question is what's stopping us from being integrated in with other, like what we do. There's probably nothing stopping, like we look at integrations all the time, and a big thing we're doing now is integrations with observability tools because they have a lot of the data and we can contribute more data back in, so Dynatrace and Chronosphere and things like that. So there's a lot of adjacencies to what we're doing here. We can be a VPA recommender. So if you're using VPA, you can just replace a recommender with us and just get a kind of a better recommendation. VPA is pretty good at bumping things up quickly, but not very good at looking at a lot of data to safely downsize things. So you know, it kind of works with almost everything in the ecosystem. So, and our customers do integrate it with a wide variety of things. Yep. Yep, Chris.
So I saw the graph about the memory and utilization. Does the alarm service like which process lead to the CPU spike or which activity lead to data using or something? So
I think the question is, do we know which process added to that spike?
Yeah.
So we don't collect down to that level right now. So we would get it kind of at the container level, and then they aggregate to the pod, like multiple containers in the pod. But we do get some process level, like we will get the process IDs for the exit codes and things like that. But we don't track the utilization of the individual processes in there, so we don't know. Yeah.
It's like a web container or pod that publishes data like STTPS, right? So that's like another layer which you're probably covered.
Yeah, so we're not measuring the web traffic, like we get the IO, but we're not getting like the transactions coming in. So we don't, that'd be kind of a different, like, yeah, transaction tracking type of thing. I think there's different APM products that probably start to get into that for performance monitoring. Yeah, so there's, yeah, we get a certain amount of data, and then we don't go down to the process level just because of the sheer volume of data that we create as well. So the container is kind of the unit right now. Yeah. So another question? Yep.
Is there a way that if you wanted to like scale on
KEDA instead of HPA VPA? And we're looking at Roy for this one. Could you hear the question, Roy?
Yeah, I think
You might want a mic. Yeah.
Yeah, we know that the phone is being scaled on KEDA, but as these metrics are totally external and are totally focused to us, I mean, we can take this information into account, but there's not much we can do with it because we do not have access to these metrics. Let's say if you're scaling on a queue size or I don't know, traffic to whichever service, That's something that in the generic analysis model, like Andrew was talking about, it's very difficult for us. But we would need to know how your workload works, and I think it's difficult in generic for that.
Yeah, the one thing that comes up a lot on that front though is, like I mentioned earlier, we just want to make sure that we're not sizing the metric that you're scaling on, because we've seen that happens. And we've seen other products do that where they chop the CPU in half and then you just get twice as many replicas, and you chop in half again, twice as many replicas, and it creates this kind of loop out to infinity. So that's the biggest one, that as long as it's a relatively orthogonal metric to what's it's scaling on. So yeah, but it's, and again, corner Rory's our deep Kubernetes guy, so you can corner him afterwards and really pick his brain if you want. Yep, other question?
Or GKE Cluster, do you guys want to Fargate back as well? Like, because it's slightly different.
Yep.
You have nodes, you have to scale it, right? You just provision.
Yeah, so we do support the Fargate launch type, and then I'm trying to recall now if it's for both ECS and EKS. Roy, do you know the Fargate launch type on EKS? Yeah, I believe so. I know we support the Fargate launch type. We support ECS as well. And I know we support it for that, and I think we could follow up and see if we do for EKS. Exactly. Yeah. So then the nodes look different. So the nodes, again, if you're on-prem, the nodes thing is not like that at all. And then Carpenter's a bit different. And we're doing some R&D around Carpenter, some interesting stuff to help produce the whitelist for Carpenter to use out of our cloud analysis.
Provision more, but here, I mean, you provision, but you know, scale and cluster.
Yeah.
Personal.
Yeah,
you don't say the same like GKE has a similar product, GKE Autopilot. It works along the same
Yeah.
principle. You pay per workload and how much it consumes, but the whole
Yeah.
node provisioning is
yeah, there's different charging schema because they in Fargate they charge per CPU and RAM.
Yeah.
In regular node they just charge per instance.
Right. And that's where, so if it's like a Fargate launch type, one of the things I think that happens is it's even more important to get the container size right, because you're paying directly for it instead of indirectly for it. Like with nodes, you pay for the aggregate that you've used across the nodes, but in the Fargate launch type, you'll just pay like directly. So you could probably compute a very much more direct cost saving right off it's just a direct function of the sizing, not through the nodes, right?
Yeah, usually Fargate more expensive if you run it 24/7.
Yeah.
I mean, it's more efficient because you cannot squeeze in instance exact amount of containers.
Yeah. Yeah, the bin packing, yeah. And if you run it for short periods and off again, it as an impact is pretty good as well, I think. All right, let's see. I think there's another question.
I have a Kubernetes service with a desired number of replicas provided min and max ranges. Do you guys have recommendations for that?
The min max of the
Number of pods.
number of pods. We get that. I don't think we generate a recommendation for that. Because I think that probably starts to relate to the business load that this thing is supporting, right? So that you start to get into the transactional stuff. So no, it's data that I believe that flows in, but we don't give a recommendation on it. And let's keep giving stuff away. Was there anything else? I think there were a few more slides. I don't know if there's anything else we wanted to cover. You guys wanted to cover?
We'll start to wrap. First of all, thank you all for spending your evening with us, and amazing questions and amazing interaction. I hope we get to come back and do the game. Really enjoyed it. It'll force Andy to come up with some new clever things to talk about. Just for follow-up, I want to send to you guys a brief survey in the coming days. If you're not selling, we're getting your opinion on things. As a vendor in the space, we like to understand what you read, who you listen to, how you participate in this Kubernetes world, events you go to, these sorts of things. It's very important to us to understand that. So if you take a moment, I promise it won't be more than a few questions, and we really value your input. If this is of interest to you, we do offer trials through the densify.com website. We are targeted at more business usage. We would talk with you about labs or smaller environments that you might have. If you're interested in understanding how this would work and those sorts of things, don't want to eliminate anyone that might be interested in the topic. So the contact form and the trial form through our website is a great way to reach out and interact with us and get right back to you. And provision one, if it's appropriate. We have very regular webinars. We have a podcast series hosted by Andrew. As you can tell, he's very entertaining, quite clever. He's a great interviewer, and we tend to invite our customers like Disney and others to come and talk about these topics. So you might be interested in that podcast. We are at all of your favorite events. The next couple are KubeCon in Europe and in North America in the fall. So if you're there, come and see us. And I think Riaz wanted to say a word. Riaz, our CEO.
Sure. All right.
Yeah.
You guys, it's Frick, Brad, Case, Andrew, and Riaz, co-founders. So the other couple things I just wanted to add was that probably the biggest topic for me is that I think that the success of the product has come by really deeply engaging with practitioners. We were lucky enough to have the likes of Palo Alto and Wayfair and Disney and a number of others where subject matter experts decided to jump on a call with us an hour, 2 hours a week and kind of refining. And so one of the things that I wanted to add here was that as I listened to the questions being asked, right? You know, I could tell by the questions that are being asked, you know, there are a lot of practitioners here. So we value that, okay? And if that comes as feedback when you just try the software, just know that Andrew and I and our product team have a notepad, right? We want to hear what you have to say, right? We believe wholeheartedly that we will get it right if we cut the layers between us and practitioners and listen intently. Okay, and so I'm sitting in the background listening to the questions intently. So I wanted to emphasize that. There are ways to participate as well, not just by listening to podcasts, but you know, if you got something to say, maybe you could be on the podcast with us. Okay, we want to be grassroots in terms of it's not us talking about Densify. Sure, we're hosting it. We'll talk about what we do, but it's just as important for us to have people like you telling us and the audience what they're doing. Okay, so I wanted to emphasize that. And the last one is a little bit of a plug. We're hiring front-end developers, back-end developers. So just wanted to mention that as well. And as Chuck said, you know, wholehearted thank you for taking the time. It's an evening. You know, and yes, we sponsored, but we also gave you kind of an overview of the product. And we truly appreciate you taking the time and obviously high degree of engagement with the questions. So thank you.
Sounds good. Thanks a lot. Yeah, thanks a lot, the team. I won't take much of your time because I still have some giveaways. I have 3 of 50% discount of the Linux Foundation examinations and 3 of the Core Cloud Premium subscription for 6 months. So I'll be quickly asking some of the questions based out of this presentation, and whoever makes the most closest guess would get the prize. So first up, and some of the questions might be basic or might not be as advanced because not all people are practitioners, and I want to give to those people who are still learning and who are still getting up skills. So yeah, so please feel free to share your opinion. There is nothing right or wrong, and let's give everyone equal chance. So first up, Andrew talked about mutating webhooks and admission webhooks. So what are those, and what are the pitfalls, if you can share, or what are the use cases of mutating webhooks you have utilized in your cluster? So you can raise your hand and answer based on whatever your experience is. Anyone mutating webhooks? Yes, please.
Yes, we so what does looking to the operations services and the words, validate the words for it's created. So we use it to inject like a public sidecar. But probably more what we had is if the thing that does the injection is down, then the configuration fails, and so they are targeted. So yeah, it's like it's great when it's working, but it's assessments there.
Can you point out any security pitfalls, because it is doing something on its own outside of human intervention? So if you can, you are a clear winner for this.
Oh, I mean, yeah, it's like you get if you break into that, I guess you access like everything in the cluster. Modify it.
Correct. Yeah, the security boundaries and the context. Yeah. So yeah, please drop by after the event, and I'd like to get your details. Second up, Andrew talked a lot about CPU utilization and resource utilization. So who can answer what's the best practice to define those key performance matrices for any application, let's say a web application or something, around which we can define the limits or the quotas for the resources? You already got the giveaway. Please give some. Any women in tech? We really appreciate women in tech, or maybe some students. You can give a shot. There is no right or wrong answer. There was a hand over there. Yes, please.
Maybe through like percentile.
Percentile, please be more specific.
99% of use. Let's say our bodies are sitting in homes. Like fitness.
And what other percentile matrices you can get to get more accurate details about your CPU and resource utilization? Sorry? Historical data, yeah, one of the answers. But since he was the first one, he gets the answer. All right, the next question I would like to ask is HPA versus VPA versus node scaling. So if you can quickly give me the differences between those and what use cases are actually for horizontal, vertical, and the node-based scaling. And yeah, over to you. Anyone? Andrew, you might want to get a shot.
The difference between HPA, VPA, and node scaling. So VPA will resize the resources of the containers, increase or decrease the individual containers. HPA will run more or fewer containers based on the load. And then the node autoscaler is the one that's running the nodes up and down based on the loads requests at the node level. So all three complicate each other.
All right. Since we did not get a response, we won't be giving any giveaway from this. But yeah, he's the clear winner always. A more generic outside this resource optimization and the discussions. What are the key challenges if you are using Kubernetes in your environment? What are the key challenges you find in setting up the resources and maybe the financial, the interaction with the financial team, they say FinOps. So what are the challenges you might want to put into attention? Sorry?
Dividing the cluster size and the cost.
Yes. So how do you explain to your financial team that you need to scale your resources or you need more budget on your Kubernetes workloads?
Smaller cluster, and then store the basic data, and then suggest we should like why should we optimize because our CPU usage is going this way, memory usage is going this way, maybe we need to upscale our cluster.
Okay, and we have one answer from over there as well. That's a good point. And have you been using any specific tools or any specific practices for financial operations or some open source cost allocation or budgeting tool which you might want to share? All right, got it. And maybe potentially the last question. If someone is running self-hosted clusters and not the managed of EKS or GKE clusters, what is the optimal way to deploy the dashboards and set up the resource utilization, and how does they can integrate some of the open source solution? If yes, please.
One of the tools with integrated with the chart, maybe easiest way to deploy self-managed clusters.
Sure, please.
Like Terraform.
Terraform is more on provisioning side.
Maybe any of the cluster, right?
Yeah, for the self-managed especially, because what managed services provides is they have the built-in dashboards and resource allocation and stuff set in. But what are the best practices for the self-managed clusters? On-prem, yeah, you could say that. There.
All the general
Built-in dashboards. There you go. All right, I am towards the end of my schedule and it's too much of talking. So yeah, that's it from my side. Thanks a lot for joining. There are a couple of people still smiling. So yeah, thanks a lot for joining. And hope to see everyone in our next events. And yeah, we still have some more swags from Densify. So please feel free to collect. There are some pens, some stationeries. So yeah, thanks a lot for your time and see you in the next event. Goodbye.